I'm messaging the gather now.
Can't have. Where's my audio?
All right.
Ah, I can hear you now.
Very good. Yeah, I muted myself because I was talking to the gather. So with us right now in the live stream is Panicz Godek and Stephen Gabrielle. And we'll be having our third session of the day, which will be their two talks. I just want to wait a little bit to make sure that people can sign on. While we're doing that, while we're waiting, you know, we'll just quietly wait.
No worries. Can you hear me okay?
Yeah, you sound great. Thank you.
Good. My light is terrible.
All right. Okay. So we now have everyone in gather on the live stream, so we can get ready to go now. So Panicz and Stephen, you want to just say hi real fast?
Hi, I'm Stephen.
Panicz, you're actually muted.
Oh, hi. Hello. I'm Panicz.
Very good. Okay, so Sorry for being a little bit frazzled about this. Like before, we'll pause the audio and video for us while we watch Panicz's talk, and then we'll do questions. You can put your questions in the Gather or in the YouTube or directly in the document, and we'll go from there.
When we learn a new programming language, we are typically presented with its syntax, that is, the set of rules which allow to transform text or a linear string of characters into tree-like structures. Most of you are Lisp programmers, so you're likely not very interested in knowing syntaxes, because you already use a very simple and effective way of serializing tree-like structures, commonly known as S-expressions. However, S-expressions are still just text. Well, okay, you're Racketeers, so you can also include images in your source files, at least as long as you use Dr. Racket as your development environment. But if you save a source file that contains some images, you're no longer capable of editing it in, say, Emacs or Vim or Windows Notepad. To my knowledge, it is usually also significantly more difficult to track changes in non-textual representations of programs, and the common version control systems aren't well suited to working with such representations. My name is Panicz Godek, but I usually present myself using the nickname Panicz. I'd like to share with you the humble results of my research concerning non-textual approaches to programming, including the ones I've been pursuing on my own. But first, I'd like to talk to you a bit about my motivation. After all, if so many programmers are satisfied with text as the fundamental representation of programs, then perhaps it isn't that bad. I realize that the Racket community is rather progressive when it comes to teaching programming, so some of the things that I'm going to say are probably going to be obvious to many of you. But I will say them nevertheless, because my experience shows that what I'm about to say has been a big revelation to some professional programmers that I've met along my journey. Are you ready? So here comes the big revelation. It is easier for us to understand concrete things than abstract things. We form abstractions by looking at concrete examples. Why do I think that this revelation is big? Okay, so have you ever read any documentation intended to be read by programmers? It usually looks like this. Blah 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 no 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 blah 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 blah. And then, many scrolls later, there is sometimes a code snippet. As a programmer, I usually care more about the code snippet than about the blah blah blah. When it comes to code snippets, they also vary in their scope. Some examples of complicated C procedures or macros present full working programs. A fairly common class of example code snippets scattered around some projects are called unit tests. Now, that's a bit controversial point. I have seen projects which contained tests that were completely unreadable but were written only to maximize a metric called test coverage. But let's assume we're dealing with a well-maintained set of tests. The developers of unit test frameworks for object-oriented languages have distinguished 3 stages in the lifetime of a test: setting up, tearing down, and actually testing whether things are or behave as expected. Functional programmers further simplify this process. Because pure functions do not depend on any state or context, they can be tested by simply checking whether the output of a given function for a given input matches our expectations. I have once created a simple unit test framework for Scheme. The actual implementation is irrelevant, but the interface is e.g. expression right arrow result. For example, and watch out carefully because I'm now going to present an example of an example. Here are some definitions of combinatorial functions. When I look at this code, I start by studying the examples. Unlike definitions, they are easy to read and really help to figure out what's going on or what the function is about. If the example is a good one, it is much more helpful than a wall of detailed explanations. I think it's also more valuable than a good name. Consider this definition. You are a bunch of sneaky Lisp hackers, so you probably know what's going on here. But when I show this example to non-Lisp programmers and tell them what the functions map, list, and apply do, or even translate this code to Python, they remain puzzled. However, when I show them this, they come up with a better name for f immediately. They also realize that the argument is named properly. So far, I've been trying to convince you about the immense value of examples, but you probably already knew it. So great, let's use examples then. I will now show you an example usage of a function g, and your task is to name that function. Obviously, you can't give me your proposal because the talk's been pre-recorded and I cannot get any feedback from you. But I'd expect the following questions to show up. Are all the values present in the output also present in the input? If so, are they in the same order? Does the order matter? Those are of course completely legitimate questions, but if we just change the way data is displayed to show it like this, then the intent should become clear immediately.
I believe that this example alone should convince you that text is a fairly limited medium, and that we should be pushing programming from text towards programmable visual interactions. That, in addition to text, we should also be able to present images, but also videos, and also things that can be interacted with. For some reason, text seems to be the privileged representation in the organization of computer systems, to the point that the phrase plain text file is often associated with simplicity and minimalism. We tend to forget that plain text files usually reside in some directories, and there are fairly sophisticated file systems to support this. I think that the idea of files residing in directories is an interesting one. Computer users usually rely on their operating system facilities to create directories and move files around them. Nobody in the right mind modifies the bytes on their block device directly, because that could cause an inconsistency in the file system. Yet, as programmers, we don't mind being able to introduce syntax errors to programs that we develop, and we seem happy that we can complain on the poor quality of syntax error messages in some compilers, and to brag about the exceptional quality of syntax error messages in other compilers. Of course, as Lisp programmers, you do know that there's no real difference between directories and S expressions, and some of you may have had an experience in using some structural editing modes for Emacs. But still, we tend to think that plain text is the omega among the turtles, or the ultimate ground. To give an example, here's a core answer to the question, why do we need so many different programming languages? What's the difference? From Gary Rzeppa, the creator of plain English programming language. It is a matter of choosing the right tool for each kind of job. Consider, for example, this excerpt from Albert Einstein's explanation of relativity in his own handwriting. Note that he uses a natural language framework with formulae, graphics, where each is most effective. This was on our minds when we created the plain English programming language. We decided to begin with a natural language compiler, planning to add in the formulae and graphic compilers at a later time. In the process, we discovered that the natural language part was sufficient for most of our program, and that we didn't have much use for the formula part, since even writing a native code-generating compiler, very little of our code turned out to be mathematical in nature, less than 2% in fact, and even that 2% was trivial stuff. When we got around to documenting our system, however, we found that we did need a way to create externalized and internalized graphics, so we added a WYSIWYG page editor, and used it to produce the documentation. Here's a sample documentation page in the editor, and here's a simpler page. So I can show you how it looks like when it is externalized or decompiled into plain text for storage on disk. As you can see, he is also concerned with how data is stored on disk. To be fair, there are approaches which break with this tradition. One example is the project of the so-called intentional programming that was developed at Microsoft before it was killed in the early 2000s. It was based on the idea of storing code in a database, which essentially abstracted from how the code looks on the disk. The presentation of code may be different depending on the contents of a query to the database. Perhaps the role of IDEs is to treat the set of files on a disk like a relational database. The aspect of plain text files, which probably dominates in our thinking, is that files are the basic unit of information exchange. They are a single message that we can send to someone. And while we're allowed to put any information we want to our message, the more assumptions the producer makes concerning the message, the less likely will they find someone who'll be able to consume their message. The most fundamental assumption that is made about text files is that it's going to use the ASCII encoding of bytes or some its derivative, presumably UTF-8. Text is a naturally ordered medium, and it is ordered in at least two senses. First, the alphabet is ordered with the order worthy of 27 episodes of Sesame Street. Second, the contents of a file is linearly ordered, from left to right, from top to the bottom. This order is so obvious that it may seem not worth mentioning, but it has consequences that are far from obvious. A while ago, I have conceived a touch-based interface to programming. It is based on the idea of nested boxes where each box corresponds to a matching pair of parentheses in a well-formed Lisp code. However, the idea of nesting boxes allows us to arrange boxes in a way which makes it unobvious which box follows after which, like in this example. This situation is inconceivable in text programming because all parentheses share the same size, so we can imagine either this or this. Moreover, since editing is touch-based, it is conceivable that the user invents their own symbols. But it may then be confusing that such symbols would not belong to any known order. Another seemingly obvious property of plain text is that it has a structure, or maybe even two structures. First, text files consist of lines. There are some essential tools such as diff or patch which rely on that structure. But there's also a more specific kind of structure. We, Lisp programmers, sometimes seem to believe that we're editing abstract syntax tree directly. But it's rarely the truth. All the code snippets that I've shown so far, in addition to their syntactic structure, contain some formatting. One could write this down as source code is AST plus formatting or comments. This means that the relation between source code and its AST is a homomorphism. That is, there are many different conceivable source files that correspond to the same AST. This relation can be lifted to an isomorphism if we find a function f such that f of AST produces formatting or comments. The pretty print function is an example of that, and so are various auto-formatting tools. The issue with formatting gets more serious when we depart from textual representation of the program. In our example of convex hull, the order of points was irrelevant, but when we represented the data as an image, we've lost the capability to express the order. We could regain it by numbering the points, though, or by drawing arrows between subsequent points. Either way, contrary to text or as expressions, this representation loses the spatiality of ordering. The problem is that we lose the isomorphism between the visual representation of a structure and its underlying textual representation. One undesired consequence of the aforementioned duality in structures of the text files, the structure stemming from lines of code and the structure stemming from the syntax of a program, is that the diffs produced between two files can be confusing and meaningless, and that patches can introduce syntax errors. Within Lisp communities, there exist several interesting projects which produce diffs based on tree structures or as expressions. One such example is Autochrome, developed within the Clojure community. Another is YDiff, developed by Yin Wang, a former student of Kent Dybvig. Obviously, if we introduce new ways of representing data, we should be able to express differences between values in terms of those representations, which seems to be a non-trivial problem in general, and as such, it should have a fundamental support from our system. This is all important to remember, but perhaps we should also consider another question. We have seen how visualizing data can be helpful, and I believe that nobody's questioning that. But what about visualizing code? That is, visualizing it in non-textual form. I don't think that anyone here seeing a nested box representation finds it appealing. Perhaps one could get used to it over time, but I don't think there's any point to this. We should be looking for representations that we find appealing and efficient, rather than merely workable. There are of course other visual representations of code already available, like Scratch or LabVIEW or flowcharts, but these tend to be domain-specific and don't seem to allow arbitrary DSLing.
Perhaps one of the easiest approaches in conceiving a visual notation is to move away from the computer and to use a pen and a piece of paper and the synthesis strategy devised in the structure of interpretation of computer programs, namely wishful thinking. Let me give you an example of this. Here's a sample piece of code from one approach to designing the editor based on nesting boxes. I don't expect you to read this code. I expect you to feel intimidated. I can also show you an example usage so that you don't feel any better. It is a fairly minimalist example. It describes 4 rectangles, with one of the rectangles containing 4 smaller rectangles. You can read that from the indentation and from the values of numbers, or to say it differently, you just cannot see it. I took this code and translated it to the following semi-visual pseudocode. It is in Polish, because I am Polish, sorry. But I also translated it to scheme-style pseudocode, which should already look fairly straightforward. The argument box actually represents 2 arguments, or a compound argument, a position laid over a box. We consider 2 cases, when the position is over some inner box and when there is no inner box at the position. In the first case, we call the defined function recursively, passing the inner box as an argument. And if the recursive call returns the argument repeated twice, then we return a pair consisting of an inner box and the outer box devoid of the inner one. If the recursive call returns something else than the argument repeated twice, then we return a pair whose first element is the first element of the value returned, and whose second element is the original argument, with the inner box replaced with the second value from the recursive call. When no inner box is hovered, then we just return the original argument repeated twice. This replication of values is just an ad hoc convention. The first value is the box extracted from the context, and the second value means the context after extraction. Instead of repeating the same value twice, we could as well use some nil value for the second value. Now, I don't expect you to get everything out of this explanation, but I hope that you're at least getting the rough idea. I have experimented a bit more with this notation and rewrote it to Haskell-inspired style. What you may find a bit uncanny is that there are some names that appear both in patterns and in the external scope, and that they are meant to refer to the same thing. Moreover, the name extract, although not misleading, isn't particularly helpful either. It could mean just about anything. So, since we're drawing on paper, we could perhaps drop textual name in form of a symbolic one. I experimented with this funny arrow, which is supposed to mean sucking something out. When I did that, I ended up with something that looks pretty much like a Prolog program. And even though the notation is very domain specific, and even if the domain is fairly small and limited, I believe it's still worth developing, especially if it's just a sub-goal of a larger quest, that is, a development of general tools for handling visual notations of different kinds, like IKEA furniture assembly manuals and other things like that. Which leads us to the last question, namely the architecture of a tool that would support such notation. It seems like a good idea to require that tool to store the data in a text-based format, because that would initially facilitate integration with existing workflows. This is, for example, what Wolfram's Mathematica does with its notebooks. However, the most important trait of such system would be its self-extensibility. The notable systems that possess this trait are editors like Emacs or environments such as Glamorous Toolkit built on Paro Smalltalk. The first prototype that I've experimented with contained a special form called define interaction, which took a symbol as its first argument. that symbol was encountered in the head of some expression, then instead of following the normal rules for constructing nested boxes, it constructed a special object according to a given rule. In this prototype, the extension mechanism assumes that the interpretation of an expression is a mutable object which reacts in its own way to events and which is able to present itself as an image or as an expression. While it is a simple and general mechanism, I don't think it is a good one. It allows the visual representation to depart from the textual one completely. I earlier mentioned the equation source code equals AST plus formatting or comments, where AST is the essential information and formatting or comments are things that are related only to presentation. I believe that the architecture of a successful system for designing visual notations needs to focus on a careful selection of constraints. One possible constraint is to require that the transformation from source code to its visual or interactive interpretation is a homomorphism. For each domain, we would probably also need a specific variant of the pretty print function. But since I am talking to a virtual room full of experienced developers, it is perhaps a good moment to handle the voice over to you, which is why the pre-recorded part of my talk ends right here.
All right, thank you, Panicz. So, audience out there, if you're anything like me, you are taking a deep breath right now. So I've been watching all of these talks to help the authors prepare them, and every single time I watch Panicz work, it I just am so exasperated by it. It's just so fascinating. I'm just stunned by when he switches to the notebook, and just if you really could do anything, what would you do? In the Racket world, we have this idea of domain-specific languages, where sometimes Racket isn't what you want. The thing that you need is something else. And I think that Panicz here has taken that idea and taken it light years away. What is the domain-specific language for domain-specific language people that even they will find baffling? So we don't have any questions that anyone has posed, because I imagine that you're like me, just so stunned. One thing that immediately comes to mind for me is, Panicz, you showed your little demo where you had the floating boxes and the die graph, and you just clicked on it and then it switched to the graph. I feel like any other person would just give us a demo. Their talk would just be about that demo. But this was a tiny sliver, a 2 second part of your talk. So can you talk more about that prototype that you've been building? What some of your ideas for where that's how that's going, and what you feel like is working or not working well about that prototype?
Yeah, sure. But could you switch on the video, because I think.
Oh, I can request that you put on your video, but I can't.
Okay, because it's okay. Great. So the thing with the first approach, it was written in Racket, and I've been experimenting with a paradigm of programming. I mean, I actually gave a talk last year at Racket Fest in Berlin, organized by Jesse Alama, where I've been trying to elaborate more about this paradigm, because I've been reading some sources of Dr. Racket, and it seemed to me that it was the extension part was in some way like ad hoc object-oriented language, something like this. And in this demo of mine, in the first one, the one with the graph, I've been trying to go to the roots of the scheme programming language, and to use sort of the original actor model which inspired scheme. So every S expression was converted to a lambda form, which was a closure that was capable of presenting itself in different ways, either as expressions or as as images or like rather interacting forms, because it was also receiving messages. And the background for this demo was a challenge that I posted a couple of weeks before, and it was just about making it was a challenge for developing or testing GUI frameworks. So the idea is just to be able to create boxes and to nest them using drag and drop, essentially. Yeah, so in that demo, it contained a simple mechanism of extension, the one that was presented in the video, that you could just define arbitrary functions that would be invoked when it receives a click or when it was supposed to present itself. And in a way, I treat that demo as a failure, in the sense that it doesn't have a good architecture because it is too unprincipled. And I think this is something that I've been devoting a lot of my thinking recently to, is that the best approach would probably be to define isomorphism between domains somehow. I don't know how to do this yet, but it just needs to be principled rather than ad hoc. And this is my major concern. And I think that I haven't seen any good approach that would satisfy me, essentially.
Interesting. I just want to mention that Leif Anderson has a preprint of a paper that he's submitted to OOPSLA on interactive syntax that may be an interesting thing for you two to talk about during the hallway time. Now, there are a few questions that people have. So Ben Greenman asks, do you have any advice for people who are making a new hashling? So, and what would be a good way to do this, and I feel like this is a smaller question than maybe you're thinking about. So, you had this very vibrant, specific syntax that was, well, not really syntax, this notation in your notebook. If you were to do that as a hashling, how could you, how might you do that?
I mean, well, this is a difficult question. I mean, I've been experimenting with hashlangs only a bit, but to me it seems that hashlangs are inherently textual, and the way I work at this moment, I just try to experiment with S expressions, and I just use defined syntax or something like this. I don't think that that at this level adding new syntax or new parser to text would be beneficial. So my concern is, as I showed you the notebook, was how to make the code look like. But the one thing that I've observed when I was fiddling with this approach to drawing boxes, and the thing that I've explained in my notebook, that it sort of, I had the original code, and going to the visual domain forced me to change the way I think about the visual code. So I would, for example, I would probably use Racket's extensible pattern matcher in order to be able to write patterns that would express, for example, that a point is over a box. Because in the original code, I was just using the find function, which was searching for all the boxes to find the one which is under the position. And this is probably what I would use, the feature of Racket that would be most useful here.
So do you believe that you could come up with the one way of creating an editor, a coding framework like this? Or do you imagine that what your end goal is a tool / language to make custom notations?
Yeah. it's definitely the latter. I mean, I don't think that the nested boxes representation is very convenient to use. I think that it could be a good base to make it essentially self-extensible. But this is why I think that the idea of having just a box is a good one, as long as the box can interpret the messages that pass into that box in its own way and present itself in its own way. I think that this is an important aspect.
Cool. Great.
So, because I've shown you two applications that I wrote. The first one was written in Racket, and the second one that was presented in the phone layout. It was written in Java, and I used. It was written on my phone actually in Emacs. I used it to run. I used the Termux app to run Emacs in my phone to write Java compiler to build APKs that could be installed on my phone, which is a bit crazy, but I think that it is an interesting way in the sense that it immediately gives me the things that I'm missing when I'm using text on my phone. I immediately know what features would be very handy to have to edit code using touchscreen. And this is actually something that the approach that I really recommend if someone tries to have fun with this.
Cool. Thank you so much. This is a cool thing. We'll talk later in the discussion area A, which is in the Northwest. We're now going to switch over to Stephen's talk.
Hi, I'm Stephen. I'm here to talk about having fun with Racket. Maybe talk a little bit about community building. I'll go over some of the things that have happened in the past year and a half and look at some pictures. I'll start with the Standard Fish Summer Picture Competition. Things got a little heated on the mailing list after the last RacketCon, and I really felt a distraction was in order. Something a little silly. I had an idea. The light bulb was Philip's idea. I've always admired the fish. It is a good fish. I promised prizes, and I was impressed by the creativity and variety of entries. Some entries started longer projects that I hope will make it into the next picture competition. This one is a design for a real quilt. I believe the entries are a showcase of Racket and Racketeers at their best, with entries that are both useful, beautiful, and fun. Racketeers come from all over the world, and I've been fortunate to chat or correspond with people from the States, Spain, Taiwan, Germany, Denmark, Italy, Czech Republic, China, Thailand, the UK, now I lived in Australia, now I live in the UK, and many more. I'm sorry I don't have a list, but it's clear to me that Racket is global. By the way, check out Alex's blog if you haven't already. It's amazing. Textuality is now a Racket package that others can try out and even use in the next picture competition. Talking of having fun and doing cool stuff with Racket, I never expected the plot library to be used. And if this wasn't enough, I was astounded by this creation, recreating a famous painting by M.C. Escher using the plot library. I'll dwell on this one for a moment to thank Bert, who submitted an enhancement to plot to make this possible. It was also exciting to have a young Racketeer join the fun. This is a waffle. Finally, I sent off the stickers and hats to the winners, and I want to thank them for their participation. I'm not sure who suggested the Game Jam. It might have been Sam Phillips, and I can't work out who supplied the lovely 8-bit pixelated banner. Please contact me as I want to credit you. I was keen from the beginning that the Game Jam should be inclusive of all sorts of contributions, not just completed games. I had no idea we would get a space shooter that runs in the terminal, a C64 game that needs a C64 6502 emulator, a board game, or a puzzle game. The year was finished off with an Advent of Code Racket leaderboard organised by Sam Phillips. The Quickscript competition happened this year. Quickscript was created by Lorraine Orso and provides powerful scripting facilities in Dr. Racket. The competition logo was created by Jens and Lorraine with the awesome Metapict package created by Jens. Quickscript is included in the Racket distribution, but sadly comes without any scripts. Instead, the Quickscript Extra package provides a starter pack of useful and fun scripts to extend Dr. Racket. The competition had three outcomes from my perspective: letting Racketeers know about Quickscript scripts as a way to customise Dr. Racket, a starting point for helping beginners, and growing a collection of useful scripts. I encourage you to try it out. To give you a taste, here are some of the more popular scripts from the Community Choice Vote. Professor Sharon Tuttle of Humboldt State University made a simple script to support learners. It takes a selected text and produces a CS111 compliant design recipe template for a function with that name. Visit URL at insertion point will open the browser to a link in your code. The image is of Robopat, a lovely script that creates a textual well done stamp to code in the form of a robot and a speech bubble. Quickscript isn't limited to functionality in Dr. Racket. The plot script uses the plot package to plot a series of numbers. Now I couldn't resist these two: an X-Eyes copy that has eyes that track your mouse pointer, and the Breakout game created by Jens. There are too many to cover, but I have one final script I want to mention: Fishy Completion by Oak. This Quickscript script allows users to autocomplete and identify via static analysis. Please check it out, it's fantastic. I need to say thank you to the contributors for their entries and feedback, and thank you to Lorraine Orso for making Quickscript and answering my questions and helping everyone who asked, and providing the t-shirts, stickers and mugs. I learnt a lot. I won't go over any more scripts because you really need to try them out. Pause the video and enter the command on the screen. I'll wait. Nice to have you back. This is a badge. Okay, it's not a badge, it's an organisation logo in GitHub. Now I've been lurking around the Racket community for some time. The earliest post I could find was 2005, but I seem to remember downloading version 2 point something when I was trying out an online tutorial in Common Lisp. I've always been impressed by how kind and helpful the community is, and I'll always be thankful for the many people who have answered my questions over the years. There came a point a couple of years ago that I came across the Racket Wiki. I started off occasionally making edits, but I eventually made a proper effort to tidy it up and add content. The idea was that by that point many developers were finding Racket not by the website, but via GitHub. While the website was linked, I thought it likely at least some users would come across the wiki. Coming out of this work was looking at the issues database. The wiki held long lists of outstanding issues that needed contributors. After some cleanup, Racket repositories now have appropriate labels for good first issue to make it easier for new contributors to get started. And the old issues have been removed from the wiki. Communication in the Racket community has changed over time. While I was used to the mailing list, there was some time before I realised that Racket discussion had mostly moved off the Racket users mailing list and onto the Racket Slack. The unofficial Racket Discord server was created out of recognition that not everyone uses Slack, despite being almost identical in many ways. It's small, but some people find it more convenient, and that's fine. A brief aside. RacketCon 2017 introduced the friendly environment policy. And in 2019, the friendly environment policy was added to the Racket website. I helped a little bit in this. Now, the Racket community is growing, mailing the subscribers, Slack, IRC, GitHub, Discord. I believe these community standards were always there, but as a community grows, it helps to codify them as a way of communicating those standards to members and potential racketeers across so many platforms. Coming back to the badge, I originally saw it as a prize. A common school of thought is that GitHub is the new curriculum vitae for developers. My thought was that giving participants this badge would be helpful to them. Loren mentioned that it might be an indicator of community membership. I know Racket isn't a football team or quilting club, but I do think racketeers are a community, a diverse one, but with individuals who have a common desire to learn, create, and share. I also put the sponsors thing there because if you can spare a $5 a month, it will help keep the servers running. I do. The latest project is the Racket templates. Thanks again to Jens for Metapict and the logo. I'd also like to thank Matthew Butterick for the Racket logo, which obviously forms the basis of this and the preceding competition logo. I'd also like to thank the community members who made it a reality. The Racco new tool was developed by Philip Dumaresque, with Windows support added by Andre Garcia. The contributed templates are Package by Jack Firth, Web App by Jens Axel Soga, the code of racketstories.com website, which you must join immediately. Hit pause now. GUI app by Matthew Flatt, a modernised version of the code for the paper programming languages as operating systems, with the Lang template kindly supplied by Sam. So what is Racket templates? It's inspired by Racco Package New and .NET New. It allows users to create a new Racket app with a single command that they can then extend themselves. These are starter examples, simple but working apps that can be adapted while giving the user a good example of Racket code. Install it with Racco Package Install from template. I'm hoping they will be useful to new racketeers wanting to make their first app, and an aid to racketeers who might be delving into a type of development they haven't done before, like moving from GUI to web or vice versa. Racket templates consist of a collection of GitHub repositories, one for each template, and a new Racco command, new, used as Racco new, then the template name. This command makes a local clone of the template specified and removes the Git history, so you can start with a clean slate. While you can use these templates directly from GitHub, Philip recently added an interactive mode to the command to customize app creation, something that GitHub functionality can't do. Racco new-I. This tool will walk you through creating a new project from the Racket template. This is all very new. You might have guessed that I'm keen on recycling, and all the existing app templates are recycled code. In good Lispy self-referential style, the Racco command template is actually the from template package that provides the Racco new command used by Racket templates. Now, do you have any code that could be recycled? Can you improve on the existing examples? I'd love to have some more contributors. Now, my original goal with Standard Fish was to make the Racket community better. Community building, as I mentioned earlier. More people learning, and more people enjoying learning, both beginners and experienced racketeers, and having fun. What I didn't expect was what I'd get out of it. I've learnt a lot and I hope to keep learning. What's next? I've got a to-do list a mile long. There'll be another picture competition, but maybe someone else will take the lead. I'd be happy to help. I'm also hoping for a second game jam. Whatever events could there be? To end off, I'd encourage you to get involved in the Racket community. There are many ways to get involved, and they are all appreciated. And the people are lovely and always ready to share their knowledge. Thank you. I look forward to talking with you on Zoom.
Thank you, Stephen. So, okay. So the first question that we have is, it would be nice if there was a way, like a web page to see all of the results of all of the various competitions and contests and game jams that you've done in the past, so that we can maybe see those. So this is, maybe that's not really a question, it's kind of a request. Can we do something like that on the wiki maybe?
Yeah, I can add a link to the, there's the results of the picture competition has its own repo. I can provide a link to that from the wiki. But I didn't do that for the Game Jam. There is the Game Jam site itself, but I'll provide a link back to the Game Jam site from the wiki as well. So yeah, they're there.
Great. Someone asks, when is the next picture competition going to be?
I don't know. I'm actually in the middle of going for new jobs at the moment, so I'm a little bit busy.
Great. So maybe once you land.
Once I land, we might do it again. But if anyone else is keen to have a go, then I'll obviously support them in any way I can. And yeah, it doesn't have to be pictures. It can be whatever works for you.
Mm-hmm. Is there a kind of jam or competition that you really want people to do? I mean, obviously people could say anything. Oh, we could do a competition about music or a competition about this, but is there something that you really wish that people would do that maybe you think would show off Racket very well?
I like the idea of a bots one, making some bots. I think that's a fun and interactive thing.
Like for like Slack and Twitter.
IRC and
interesting. Yeah,
whatever. Yeah. It's a nice public one. You can have a lot of fun with it.
Mm-hmm. Awesome. So what was the reason that you originally got into Racket?
It was quite a while ago. I'm sort of struggling to remember. I think I'd read portions of Paul Graham's on Lisp, and I thought all these Lisp languages seem like a bit of fun. And someone mentioned Scheme at some point, and I eventually stumbled over an early version of Dr. Racket, version 2 point something. And I've sort of, been on and off ever since, depending on how my life's been going. But it's I keep on getting drawn back into it. And as I said in the presentation, I've learned a lot. I'm lucky to be around first-class educators like yourself. I ask questions and I get fantastic answers. So it's the people that keep drawing me back, and I've learned so much. I can't thank you enough.
Awesome. Well, I think that you've made quite the great contribution to the community as well. Recall that this morning when we were talking about what people were most excited about, I think that most of the things that people said that they were excited about were things that you were involved in helping people run and doing the competitions and contests and really getting the word out in activity. So thank you so much for that, Stephen.
No worries. I would like this to add before I go that there's lots of ways of contributing, and hopefully I'm just an example that you can actually just take a left turn and do something completely different, and it still helps the community. So if people out there have ideas, please go for it.
I think that's a great point. The only contributions that are valuable are not, a new type system with some paper and some fancy macro system. Like Racket is so much more than that, and I think that no one needs permission to do great things in Racket, and I think that you have demonstrated that remarkably well. We're going to switch now back to the Gather. So we'll have in the discussion area A, we'll have Panicz, and discussion area B, we'll have Stephen and people who want to talk about these kinds of projects. So our next slot will be at 4:30 Eastern time, which is in about an hour. And that'll be Ben Greenman, who will talk about shallow typed Racket, something that was alluded to earlier. And then we'll have the Ask Me Anything for Matthias. So be thinking about your questions for Matthias. It'll just be a conversation between where we can ask Matthias about his perspective over the last 100 years of computer science research and education. So we'll see you all soon. Thank you.